This conference will now be recorded.
Thank you, everyone, for joining us today. We have a special pleasure of having Kevin Perrys with EXFO to discuss OTDR testing with IOLM on unbalanced splitters. Kevin's going to go through what exactly an unbalanced splitter is for those who don't know that, and how EXFO is being able to test that in an effective and a highly effective manner. Now, having Kevin with us today is a very special time. He's for those of us who know us at S&S, generally we can answer a lot of your questions. But Kevin is one of the people that we go to if we can't answer your question. He is very knowledgeable. He's an applications engineer along with the Advanced Technologies and Solutions group at EXFO. Kevin has been with EXFO for 18 years and has been involved in the telecom industry for 29 years. Starting in excavation as a laborer, Kevin traded in his shovel for a backhoe, laying cable across the U.S. He later worked for a Tier 1 service provider as a splicer and tester, working on new installs and disaster recovery. Kevin became an operations technician, turning up and maintaining DS1 to 10G systems. Leveraging this field experience, Kevin delivers a unique perspective, which shows in his educational approach when delivering expert content through webinars and seminars. And without further ado, I will turn it over to Kevin.
Perfect. Thank you, Charlie. And thank you to the folks at S&S Solutions and for all of you that have joined today. My introduction there was a bit of a mouthful. Our marketing department is pretty wordy, apparently. So, I'm going to go ahead and kick it off. So essentially, what we're going to cover here is OTDR testing with IOLM on unbalanced splitters, right? And so using kind of the advanced OTDR that we have and the intelligence of it to be able to test some of these, more complex networks, which is ironic because it's complex in the way that it's tested, but it's simple in the way that it's deployed, which is one of the attractive things about deploying these kinds of these systems today. And so we'll jump right into that. And so essentially, what we'll cover here today is a little bit of the market overview because it's important to understand what's driving, the deployment of unbalanced splitters, and some of the market drivers behind that, right? And we'll talk about the legacy PON systems that we see, kind of the cascaded systems, the centralized systems, and how they differ from what we're talking about today. And then we'll get into setting up a test and actually looking at results and doing some reporting. And so I'll go ahead and jump straight into it. And so what is driving, all of this technology, right? Why are we doing this kind of testing? And quite honestly, to a large degree, a lot of the fiber to the home deployments that have been performed, throughout the country here have been more in the urban environment, right? So cities, densely populated places, back-to-back, easements of homes and stuff like that, using centralized or cascade split systems, right? So 1x32 feeding 32 subscribers, or a 1x4 and into a 1x8, those types of things, right? So kind of like these set, architectures. But what one portion of the market that was largely ignored is really rural broadband. And so we're pushing ADSL as far as it'll go to try to get broadband speeds to some of these customers. But the cost of just, deploying fiber to these remote locations is not very cost effective, right? And if you're going to utilize the same type of architecture that we're using in an urban environment, then it really starts to get pretty expensive, right? And so there is a big market for rural broadband services. You can see that there has been obviously some funding provided for that, the unserved broadband markets, as they like to call it. And so that's kind of what's driving some of this, right? And so why are we seeing, some of these advantages with unbalanced splitters? One of the big advantages, if you think about it, is less cable and smaller cable, right? And this is actually a big point. So back when I used to work construction, well, a large count fiber for me 20 years ago was 96 fiber, right? Nowadays, we're seeing 1728s, 3456, these very high count fibers that are being deployed in a lot of urban areas, right? But certainly out in your rural country, you're not going to run an 864, overlashed onto a pole line somewhere, right? It just doesn't happen very often in most situations. And so one of the big advantages, again, is less cable and smaller cable. No need for cabinets. So you can have just, splice cases and terminals that you tap in and out of with your drops. Simplified splicing. And so if you picture some of the splicing that's required for high count fiber in a standard pond system, going from a 432 down to a 96, and so very complex splicing, and of course just overall cost. So the overall cost of it. In fact, I'll go ahead and draw because I like to draw here a little bit. So anybody who's seen any of my presentations know that I like to draw just a tad. So this is a bit of a whiteboard here, right? And so, down here at the bottom, I kind of got just a basic high-level overview of kind of an urban deployment, right? And so if you picture what we're doing today, essentially we're running fiber, over to a specific location, right? And so this could be to a 1x32 splitter. This could be to an OLT, because sometimes the OLTs will be housed inside the office, and sometimes they'll be in an environmental cabinet out in the field. So really depending on your deployment. So in this case here, we have fiber that runs basically from your office, to a centralized location. And so in this case here, we'll say that it goes to a splitter cabinet. And you might have, say, 8 fibers that are peeling off of this larger cable feeding this one cabinet. And this one cabinet, let's just say it's a fixed 1x32, right? So we'll say it's a fixed 1x32 split here. And so we're splitting up to 32 times on 8 fibers, right? So we're looking at close to, what is that, 256 fibers? So you have 256 fibers being fed out of this cabinet into this urban market. And so from there, obviously, you'll be feeding all these individual subscribers, right? So feeding all these individual subscribers. And so we're talking about some very high count cable, a lot of splicing. So this is a traditional fiber to the home system that we're seeing today, right? This is what we're seeing today. So we're seeing high count cable being placed out in the field. In this example, 256 fibers are coming off of this one cabinet. It's feeding a lot of subs, potentially, but typically you're not getting all 32 subscribers on every single splitter port, right? That's not typical, but certainly it could happen, particularly in the MDU market, right? But if you look at a more urban environment, right, we're talking about some great distances between the office and your subscribers, right? So we're talking loops well over, the 10,000 feet or more that you would need for some sort of DSL, right? And so in this case here, you're also doing, so this is going to be more of an environment that is, again, rural. Certainly you can go in here and place a fiber and have a 1x32 splitter and try to split it off, but you're going to start losing power because that 1x32 splitter is going to have between 16 and 18 dB of loss. So your loss budget is chewed up quite a bit at that first location, which doesn't leave you a lot of budget for the drop or the end part of it, right? So if I were to go in here and place, this 1x32 splitter here, I would lose, we'll do even money here and say 17 dB in my power budget. Most fiber to the home systems engineered around 25 to 30 dB, depending on the classifications. So now we're burning it up, burning up a lot of our power. In an urban market, we're not running more than 1,500 feet to 5,000 feet or in that range of, distance between the splitter and the subscriber, right? So the subscribers are in fairly short distances, so we're not getting a lot of attenuation from splices and connectors, right? But in this case here, if I'm trying to feed this last subscriber here, and let's say they are 5 miles down the road, we're starting to accrue some attenuation from our splices and whatnot. And so our loss budget isn't near as attractive in a situation like this. But if we looked at an unbalanced network with taps, so basically what's happening here, so when we're talking about unbalanced, what we're talking about more is taps. So percentage taps. Taps have been around for a while. Anybody who's in the MSO market, there's this very similar technology being used or architecture being used in the cable TV space. But when we're talking about taps, what we're talking about is percentage taps. And so with the splitter, with the splitter that we were talking about, right? So with the splitter that we were talking about, there's different splitters, whether you cascade them, right? 1x2, 1x4, 1x8, and then the most common that we see in a lot of deployments, 1x32. We can go up to 1x64 and 1x128 with EPON, but traditionally we're seeing 1x32s or cascaded systems, right? So these all have fixed attenuation, right? So, we're roughly around 10 dB here, and we're roughly around 17 dB here. And so the problem is that, you're losing all your upfront attenuation at the very first splitter, right? Where it would be, and those subscribers that are very close to that splitter are going to have good power levels. So this subscriber over here, they'll get a neg 12 dBm, right? Or whatever. But the problem is that the subscriber at the very end, because they're so far away, is going to be right on the bleeding edge of working, if at all. So they're sitting over here at minus 25 dBm or in that range, because we burned off all the power in between, right? And so that's one of the challenges we have. And so with unbalanced splitters, we're trying to get around this by slowly leaching off the power. And we're doing this using taps. And so the taps are based on percentages. And so you might see, and I'll just type over taps. And so you might have a 95-5, right? 90-10. And so basically, this is, what we're looking at when we're talking about taps, right? 95% of the power goes on, 5% of the power stays for the drops. And so that's one of the first specifications that we're looking at, right, is these percentages of taps. And then we also look at the ratio or the number of drops that comes off of it, right? You can have 2 drops, you can have 4 drops, whatever. And so depending on how you have it deployed, so now you can slowly cascade or bleed your power off, right? So I can get in here, and on this particular pole line, I can say, you know what? I want to add, I'm going to get fancier and put a riser. I'm going to add a splice case here, or a tap inside of a case. And then I'm going to go ahead and do this one at, 99.1. So 99% goes on, 1% drops off. And I'm going to put in here a 1x2 drop terminal. And so out of that 1%, a portion, half of it's going to go to this home, and the other half is going to go to this subscriber, right? And then the rest of the signal, the rest of the 99% goes on to the next location where we do the same thing, right? We're going to add another terminal that has a tap, and in there we're going to have, whatever we want there, right? So we might say 95.5. So however you engineer it, and this one is going to be a 1x2 or whatever you need. And so you're going, as you're going on and on and on, you're adding more and more, right? And so one of these locations could have multiple homes, so you could do 1x8. So you're slowly bleeding away the power. Where before, when that signal came into that 1x32 splitter, it would come out of that 1x32 splitter. Let's say it left the office at 0 dBm and it lost, a bit. So by the time it arrived at that, on the other side of that splitter at minus 16 dBm, right? And so now they have minus 16 dBm. Where in this particular situation, if I'm just bleeding off 1% of the power, I'm going to have much, much more light. I'm going to have something closer to, neg 1.9 or something like that, or 1.0 or in that range, right, dBm. And so if I tap in the power, I'm going to have a lot more power available to me, so it'll slowly leach away as it goes down the span. And so when I talked about some of the advantages, one of the advantages I talked about was the size of the cable, right? So the size of the cable really matters, because in a traditional system, I'd have a high count cable here, maybe a 432 or something like that on these intermediate spans. Where with a unbalanced system, I can get away with smaller fibers. And so when we're looking at this system here, I have 8 fibers feeding 256, right? So there's 256 fibers on the other side of this cabinet in this example. In this example, I can feed 256 customers off of 4 fibers. So I can even have 4 fibers that run down this pole line, and each one of them will have its own percentage tap, and then we can keep pushing it and pushing it and pushing it, right? And the size of this cable here doesn't need to be very big. So you might get in here and just have a 12 fiber cable all the way through here. And I'll change the color here so it's easy to read. So I don't need a big 432 or 288. You know, I might need only a 12 fiber here because I'm only using 4, right, across this entire span. And so what does that mean for me? Lower cost, less splicing, smaller cable. Smaller cable means you can put more on the reel. The more cable you can put on the reel, the more you can string out without splicing it. So less splicing, less cable, less weight on the strand, you know, the whole works. If you put a big cable up there and try to do an overlash, I don't know how many times I've, you know, back when I was doing line work, you'd have to get up there and upgrade your strand. And then all the down guys and resag all the poles and all this stuff involved, right? You'd have less complications on the construction side, on the splicing side, and on the testing side. And that's what's happening here, right? Is we're splitting the signal. And this is all just one fiber, right? It's all just one fiber. So if I go back to my deck, and I have a habit of skipping around on a deck, and this is a rare occasion where I actually have one, right? I usually just almost 100% whiteboard, but I wanted to have, you know, some, you know, some images, you know, for you here. And so, you know, again, to kind of, you know, come back to what I was talking about before, right? This is what it looks like in a centralized splitting environment. This is what it looks like in a cascaded environment. This is what you're seeing a lot of today in more urban markets, right? So we talked about that. And then this is what it looks like in an unbalanced splitter market. And so this is where you're doing the taps. And I wanted to show this particular one because this, instead of drawing all these blocks, I'm going to cheat and use this one here. But essentially, this is one fiber. So you have one fiber coming in here, right? So you have one fiber that's coming in here. And basically what happens is it goes through this tap. 10% of the power is going to go to these 8 drops, right? So 10% of the power is going to feed these 8 customers. That's what's happening here, right? 90% of the power is going to go right through to the next tap, right? And so once it hits this next one, another 10% bleeds off and goes into here, and then this keeps going, right? And so this is essentially all still one fiber. The only place where you have multiple fibers is the drop, and that's all drop terminal stuff anyways, right? So this right here is all one fiber. This entire thing, as it traverses the network, is all one fiber, all the way to the end. And so that's one of the advantages of having this kind of infrastructure. So you can kind of see what we're doing there, right? You're kind of seeing what we're doing there. If you want to look at this from a loss perspective, you know, basic loss perspective, it might look something like this, right? So you have, you know, 11 dB of loss feeding down to here, right? So 11 dB of the power, and then the rest of it keeps going on. And so this is how we're doing it. And it's just simple taps. Like I said, if you come from the MSO world, this is something that you've seen, you know, similar infrastructures like this. But now we're starting to see this more and more for fiber to the home technologies on the telecom side. And so that's one of the great advantages here. And to give you an idea of what the closure, some of the closures might look like, there's different vendors out there. This just happens to be one that I, you know, grabbed an image of. But essentially what's happening here is we have the signal coming in. Let me scoot this over here. So basically we have the signal coming in onto one side. See my pen will work here. There you go. Comes in from one side. And then it goes in and gets tapped. And then the percentage tap feeds these 8 drops, right? So we'll say 10% is going over here to feed these drops. And then the other 90 is coming back out here and going to the next terminal. So it's kind of just daisy chaining it back and forth, in and out, stealing a little bit of the power to feed these drops and then progressing on to the next location, right? And so one of the complications is, you know, when you're shooting with an OTDR or the older IOLM, how do you identify what, you know, what that's, if that's the splitter or if that's a high splice or something like that, right? And so that's where you can start defining, you know, how you set up the test, right? Because it is, you know, if you look at some of these loss, you know, parameters, and it's kind of hard to see here, but over here to the right, you can kind of see what I'm talking about, where, you know, a 1% tap, you know, bleeds off about 0.3 dB of insertion loss. A 0.2, so a 2% bleeds off about 0.4 dB. So how do you know that this is a tap and not a connector, right? And so this is where identifying a configuration comes into place, and we'll talk about that when I fire up IOLM and we talk about configurations. But you can see just how close these loss values are between these different percentage taps. So that's one of the complications that we have, particularly with an OTDR, because an OTDR doesn't have the intelligence to differentiate between a connector and a tap, right? It just sees loss. And so because it has nothing to compare itself to, right? And so that's something that that we have to keep an eye on. And so looking at it from an OTDR perspective, this is what it looks like, right? And so kind of mixing the look of the view, and of course all this testing is done from the subscriber side, right? Because we still suffer from the same issues that we have testing through a splitter. So if you're at the office testing back through a splitter, when that OTDR or IOLM hits that splitter, it's going to split up to 32 times or so, or whatever splitter you have, and measure all 32 drops, and then come back with just multiple spikes, right, on one flat line. So this testing is still done from the subscriber side, but this is what it would look like with an OTDR. It doesn't really identify very well. And with the older IOLM, we're having the same issues, right? Is being able to detect those losses. And that's where building a configuration or link definition comes into place. So as you're designing your system and your records, obviously records is always an important thing and always a challenge for most of us, is understanding the type of taps or unbalanced splitters that you're deploying, right? And then how you're deploying it. A lot of companies that we've been working with lately kind of have a mix of 2 or 3 different ways they deploy, right? So they're always deploying a 90 by 10, followed by a 90 by 10, followed by an 80 by 20, etc., right? And so they have a couple of mixes of those. So what you would do is you create a configuration that matches the way that you've deployed your splitters, right? And how you've put them out in the field. And so that's a big part of it. So with IOLM, if you already have IOLM, all you have to do is update your unit and you'll have the ability to create these link definitions. And I'll step you through that, right? Because I like to log into the equipment and do that as well. But it's important to be able to, to identify these spans. And so with the link definitions. And reading it and interpreting the data is going to be important too, because we're testing from the subscriber side. What you're going to see now is this icon that shows this is the CO. And this is where you're testing from, right? You're testing from the subscriber side, wherever you happen to be. And once you create the configuration, it lays out this map saying, okay, I'm expecting 2 90 by 10s, an 80, a 70, and a 60. And so when you test, IOLM will look at those, look at the map that the configuration that you created and compare it to what it sees in the field. And that way it can differentiate, hey, this is a tap, this is a high loss event, right? Based on the information you put in there. And so as you're testing from these different locations, you'll see how these populate. So the 60 by 40 is way over here because that's where you're testing from, and that's by the ONT. So essentially what you're doing is you're testing through multiple losses here. You're testing through a 1 by 8, which is about 10 dB of loss, right? Then you're testing through additional loss and more additional loss as you're going through it, right? And so you're testing just on this side here, and it's only testing this one fiber going through the system here. And so you'll be able to troubleshoot and identify your different taps that are out there. And so, and again, that's one of the biggest challenges there. And so, in fact, I didn't need to go there. And so with that, I'm going to fire up my VNC here. And so I am using the FTB1 Pro with the FTB X730C. So this configuration is available for the Max 730 and the FTB X730C as well. So I'm going to go ahead and just fire up IOLM. And this is not an IOLM course. I have courses where I do advanced IOLM and OTDR and all that other stuff. This is really more to kind of walk you through how to set this thing up. And so let me do this right here. Let me move me to a much smaller section here. So essentially what I'm going to do is, so from within IOLM, right? So this is IOLM. It's the Intelligent Optical Link Mapper, right? And so it allows you to create configurations for different types of test applications. And we're coming out with more and more of them. So if I were to hit test configuration here on the right, you can see some of the pre-canned ones that I've made here recently, right? And so I have some for front haul testing, some for testing through wireless CPU interface taps that we do from some mobility customers, some specific projects. different types of deployments. If I'm testing through 1x32 stuff, if I'm doing F2 testing on PON, so IOLM, so the message here is IOLM allows you to create custom configurations that are very specific to your network, right? We even have one called SFP safe mode that, especially for DWDM transceivers, you can blow out a DWDM transceiver if you use auto mode on an OTDR, or if you use a standard configuration on IOLM, because it'll burst high energy and blow out the SFP. So we have something for that. We have a configuration that looks for events. It spends a lot of time, with a lot of averaging time, looking for events that are close together, right? And so again, you have a lot of power, and one of the ones that we have is unbalanced splitter. And so normally what I do is I will take the default configuration that comes with every machine. I will duplicate it. So I'll go over here and duplicate it, and then give it a name, right? And so in this case, we'll just say unbalanced, and I'll say demo because I'm going to dump it later. So there we go. My VNC is trying to catch up with me, I hope. Lagging a little bit here. So it says unbalanced demo. So here it is right here. Then I'm going to modify it. And then here's where I can set up my information, right? I can set up what port I want to test out of. Do I want 1310 and 1550, one or both, whatever, right? Under link definitions where we want to go. So link definition, you'll see where it says splitter type. If you're just doing a standard splitter type, great, 1x32, 1x30, 1x12, whatever. I'm going to go to unbalanced. And once I do that, I have this option here for splitter settings. And I go in there, and this is where I can define my splitters. I can say, you know what? My first two splitters are 90x10s with 8 drops, right? Or 2 drops, whatever. So I can drop this down to choose whatever I want. And so I'll say my first two are 90x10s. My third one is going to be an 80x20, and then, so on and so forth, right? It keeps dropping down and down and down, to wherever you want it to go. And then, of course, you can change the ratio. Say, you know what, this is only a 1x2 drop. So there's only 2 drops at that location. And this one's a 1x4. And so within the software, we have all the parameters for loss at those particular ratios, right? And so you would just define how your network is built. And, this is the closest to the office, and this is the closest to the subscriber, right? These are the closest taps to the office and subscriber. So I go in and just set those up however I see fit, and then just hit OK, right? And so that's the simplest thing to do in there. So once I've done that, once I've identified, basically, what it looks like, right? So this is what I'm going to be testing. All right, I'm going to be testing 290s, an 80, and a 70. I can also go in here and type in anything that I want. So I can go in here and say, you know what? I want a 55. And then as soon as I type 55 and hit drop down, it tells me 55 to 45. All right. So if there's a tap that comes out that's atypical, then you can go ahead and put one in that, and then we will just set the thresholds based on what the expected loss would be for that particular kind of a split. And so once you've done that, you go to pass-fail configuration here, and then you can set your pass-fail configuration. Now it's a little bit different. I have an option for data center testing, but really you would just go in here and you get in here and then set your splitter thresholds and reflections here. All right, so here's all the different values here. So if you have a pass-fail threshold that you internally manage, then you can do that, right? And so you'll have the splitter, then you'll have the port. Those are the two, right? And so once you have all of that set for whatever type fiber you have, and again, I have a data center option, so I can choose OS1 or OS2 fiber. For those of you that do data center testing, that's probably familiar to you. And hit OK. And then once I close, then I am now in that configuration. And now you can see how it kind of lays itself out, right? And so the testing is going to be from the subscriber side. So we are testing this way, essentially. And I don't have an untapped system. I did put some attenuation in there. We'll see if we get lucky and hit one. That's close enough. So, in this case here, I'm just gonna, I'll do 1310 and 1550, both wavelengths. I have a a 67-foot launch cable. I have like a 20-meter launch cable. I don't need a long one for IOLM. That should suffice as long as I have a good launch. And then I just hit start IOLM, and then it'll run through and then kind of map things out for me. And hopefully we'll have something here. If not, I have some saved configurations for some actual testing that was done on a system. But we'll let it run through and do its thing. And essentially, again, what we're doing is we're just trying to see if we can identify any of the taps. So we'll let it run its thing. So it's about 10,000 feet here. It's pretty decent sized distance. I want to have an attenuator in there is what I had. I might have put a macro bin in there as well. I did it late last night, so. But we'll let it run. We'll see the progress down here in the bottom right. And we'll also have custom reports for this. So if you are one of those folks that use something like Fast Reporter, so within Fast Reporter, we can create custom reports. We do have some new custom icons now that tell you, basically what we have here, right? And this is just one of the pre-canned ones. So, these are 50-50 splits here. These are 70-30 splits. And so we have these custom icons, that'll basically tell you it's an unbalanced splitter. And of course, we can sit here and look at the different loss values for these as well. So this is what it looks like, from an icon perspective. And once the testing is done, and it's still going, we'll see what we have here for results. Let me move back over to there. And it's nearly done. It's behind my head there. So, and again, if it doesn't show us any taps, I'll pull one up because I don't have access to any taps here in my office. So I actually live here in Goodyear, Arizona, so I'm not too far down the road. Let's see if it picked anything up. Yep, picked one up. And so, so it basically picked up, well, just the end location. And so, because I have quite a bit of attenuation there, but to give you an idea of what one looks like, I have some saved. Let me see here on a thumb drive. So look at this one here. And so this gives you an idea, and it looks kind of like what it looked like in Fast Reporter, right? And so as we select these different ones, it basically identified what we have here. So there's a 1x4, 1x8, and so kind of the different ratios here and what it expects to see. And then from here, obviously you can generate a report if you want. On the unit itself, you can hit report and that'll generate a PDF. Or you can have custom reports. So like with IOLM, using Fast Reporter, I can get in here and create a custom report, or I can just do a canned report here, something like this. And so that'll generate basically a PDF that I can view. I can also look at it from an OTDR perspective as well. And so if you have the iAdvanced option for our IOLM, so it's called the iAdvanced option. If you go to element table here, and this is something I fought for a long time because I like to look at graphs as well. I'm an old school OTDR guy. So I hit the graph up here, and then it'll open the file basically in an OTDR, like an SOR. All right, so if I zoom out here, this is what it looks like here. So I can get in there and look at specific events and zoom in, zoom out, all that fun stuff, like it would be an OTDR, right? And so there's one of our taps there, and there's a couple of them up here in the front. So we're still able to do that, which is nice. And if my report pulled up, I don't think it did. I think it just saved it. Let me see here. Let me see if I can get this report up here. Oh, it's in downloads. Okay, let me go open it. I'll show you what the report looks like here. There we go. There it is. And this is what it is right here. And so you see all the tap and splitters. There's an OTDR graph that I included with it, and then of course all the specifications for loss and the characteristics of the, of the different splits. There we go. Perfect. And so to kind of summarize everything that I talked about, right? So when we're looking at the advantages here that we're seeing, so the big advantage obviously is going to be for the rural market. The advantages that we talked about are fairly clear, right? Smaller cables, less complications with splicing, cost-effective way to extend your network. Some of the disadvantages, though, is upgrades is one, right? So if you want to upgrade one of these networks, you're all on the same fiber, so you have to upgrade everybody. You can't just have one customer that's upgraded, right? Everybody needs to be upgraded. And so because it's just one fiber that runs all the way through. So that's one of the biggest issues there is as you transition to faster technologies and what like that, then you'll have to update everybody. Well, right now with an overlay system, when you're looking at a standard PON system like this, what we're seeing a lot of now is cohabitation of different types of networks. And so if you look at the traditional GPON network that we have, available, it's, or even EPON, it's 1490 nanometers downstream, right? And it's, it's roughly, 1.4 gigabits or 2.4 gigabits, depending on which direction you're going. And then you have XGS PON. And XGS PON is basically 10 gig PON synchronous, right? And it's going downstream at 1577 or in that range. And so, and then we have other PON technologies that are coming up. There's 25 gig PON, 50 gig PON. There's even 100 gig PON available as far as standards go. And so we're scaling. NG PON 2, which is 4 wavelengths of 10 gigs. So we're looking at 40 gigs down and 40 gigs up, right? The beautiful thing about these networks here is, you can overlay them pretty easily, right? You can add 1490 to 1577, and change customers' equipment and whatnot. So we're seeing that. So we have some of that flexibility with what we're doing with untapped splitters, but there are some limitations that we run into there. But that's kind of the two big ways that we're delivering these systems and some of the issues that we're seeing around it. From a testing perspective. And again, if I were to test it with an OTDR, so if I were to start up a standard OTDR, and most of us have probably been using OTDRs for years, an OTDR is just going to tell you what the loss is of this system. And so I'm going to go ahead and put a pinch in here just so we have something that's showing some drops. And I'm going to disable 1310 just for this example. And I'm going to get in here and adjust the setting. This is just for demo purposes, so don't pay attention to that. And so I have a pinch in the fiber. I'm just going to go ahead and use this setting because I used it earlier, so it should be good. And I got a little pinch in the fiber, and then we see multiple, more than a little pinch, right? In this case, we'll pretend it's a tap, right? So it's an unbalanced splitter. So when you look at it in OTDR, when you click on this event that has the high attenuation, it's not going to know what it is, right? It's going to assume that this is just a bad connector or a bad splice. Or if I had 1310 on, whether it's a macro bend or not, it's not going to tell you, oh, you know what? I'm expecting a 5 dB loss here. This is a tap, right? And I'm expecting to see a tap, so I'm looking for it. I identify it. And if I compare it to 1310 and 1310 has higher attenuation, then I know it's not a macro bend, right? But the software is not intelligent enough to do that because OTDRs don't have configuration files and analysis like IOLM does. And so that's one of the big advantages that IOLM brings to the table is that it does allow you to customize your configurations, to get in there and kind of set it all up, the way that you want and need. And so let me switch screens here. Sorry about that. And so basically, it's all a matter of knowing your setup and how you're deploying your systems, right? Are you using 90 by 10s? Are you doing, or is everything 1 by 8? Or are there 8 drops at each location? Is there 4 drops? So these are some of the questions that you have to ask when you're starting to deploy this stuff. And of course, a lot of that's on the engineering side. And so to kind of summarize what we talked about, from a market overview, we talked about where a lot of the technologies are today. And we're seeing a big shift. In fact, there's more fiber being put in now than in recent memory. And with 5G and higher speed requirements for our subscribers and our customers and internally, we're trying to find new ways to get services out there to unserved markets. There's funding available from the government to do that, for this broadband initiative for unserved markets. And this is one of the architectures that takes advantage of that, right? We're still going to be seeing a lot of, the cascaded and centralized splitter environments in urban markets. That's tried and tested. We're still going to see a lot of that. But now we're going to start picking up some of these, these markets where we're starting to place these percentage taps through the network, so we can get services out to that farmhouse out in the middle of Buckeye, and stuff like that. And so we talked about the different architectures and why they're relevant. And then, exactly what unbalanced splitters are, how to use IOLM to set up and then to do reporting. Because at the end of the day, we need that closeout package. And then after that, it's just, kind of analyzing the results and understanding what you're looking at. And I think it's a good idea. And maybe that's something I can send in the follow-up. I'll get with the folks at S&S, like a chart of all of the attenuation, the loss based on the different types of taps versus the different types of ratios. There's some pretty good tables out there that talk about that and how that works. Because then that'll give you a better idea, because when you're looking at like an IOLM trace, when you're looking at an IOLM trace, in this case OTDR, just so I don't have to run another test, you'll be able to understand your loss environments, right? If you know that at this location right here, that this is a 90-10 tap and it has 8 drops on it, but you're expecting this to be 2 dB and not 5, then that's important to know, right? So for your analysis and troubleshooting and stuff like that. So setting your thresholds will certainly help with that as well. But it's good to know that information, because most testing is analysis anyways. So when you're doing troubleshooting, if you're trying to reduce your MTTR, understanding the different parameters and what's good and what's bad and the thresholds is important. So I will see if I can dig up. I know I have one, a table that has all of kind of those those loss readings, and I'll send that. So I also recorded this locally just in case this did not stream seamlessly, because sometimes there's a little delay. So if I'm moving around, my mouth doesn't match my audio. So I have a recording of this that I'll send to Charlie and them, so they have a clean copy as well, so you can review. I'll also include some additional stuff, how to set up IOLM, maybe some little additional content that I've done. Somebody mentioned some of my YouTube stuff. I am on YouTube apparently, and there's quite a bit of folks that watch videos on there, and so I might share some of those links as well. So with that said, let's see here. I guess I'll take any questions that you might have.
Yeah, I got a quick question for you, Kevin.
Sure.
Are you currently doing field testing for these splitters? And if so, are you seeing like average loss, whether it's per distance or per splitter? Are you seeing averages as you're testing these, or are you still kind of I guess the main question I'm kind of trying to ask is, do you see, is there a standard that you look at and kind of know that when you're looking at these splitters that you should be looking for a 2.5 loss at this splitter, or a 5 dot loss, or whatever it is? Are you seeing averages when you're testing these?
Yes. And so and I can get some additional data for you, right? Unfortunately, I haven't been out in the field much, not since last March. I went from 220, 30 days in the field to none. And so I've seen a lot less in person, but certainly within the thresholds that we have within the unit, I can get you a list of all the thresholds. So the thresholds that we have set are based on the thresholds that are expected for those types of percentage splits. So we know exactly what the loss should be for a 99-1, right? Because it's really based on the the incident power of the IOLM or the source versus what comes out the other end, right? Just standard loss testing. And so we do have those values, and that's something we can get you.
Okay, great.
Yep. Any other questions? Everybody's speechless.
I think you covered everything really, really well.
Oh, good, not good. I'm glad. Yeah, I mean, it's 45 minutes. We wanted to kind of just get a high level overview. I like to start with some technology in there because I can go in there and just go straight to the product and say, hey, we have this config. But I think it's really important to understand where the technology is coming from and where it's going. It's amazing how much advancements and changes that are happening right now. When I was a tech, a T1 was around forever. It was T1, T3s. and then you might have an OC3 and an OC12, right, from a telecom perspective, and you had that for 20 years or whatnot. Now it's, we're seeing, I just did a seminar yesterday on 400 gig technologies, and now we're doing 800 gigs. And Ethernet and Sonnet and T-carrier and all that stuff and DSL, it's all still around. We're just getting faster and faster rates. But the architecture is also changing, right? We're starting to see multi-fiber connectors like OptiTips and multi-fiber hardened connectors, and we're starting to see smaller hardened connectors, out in the field as well, and different types of closures, and obviously the different types of fibers now, right? With these high count fibers, looking at 864s and the way they're trying to get them into smaller and smaller ducts, right? And so there's a lot of companies like, Prismium and a bunch of others that have done some really amazing things to get more density out of the cable to fit it into an interduct, which is cool because, years ago I placed a lot of interduct all over the country, a lot of 1.25 inch, and larger, up to 4-inch ducts, right? 4-inch ducts are mostly in the urban areas. But, this is kind of going the opposite direction where we're going back to smaller cables, using kind of a simplified technology that I think will be, advantageous for a lot of those customers that have a lot of rural environments. So hopefully this was helpful in kind of guiding you towards, or helping you understand some of that. And certainly, always free to reach out to anybody at S&S or out to myself if you have any additional questions or want some additional details on or more specifics, and we can certainly help out with that as well.
I actually have a question. Can you explain the 90 by 10 and how it goes from 90 by 10, 90 by 10, and then you drop off?
And so it's 90, yeah. So it's that's a good question. It's 90% of the total power at the time, right? So if I'm arriving at 0 dBm, 90% goes on, and then 10% stays. The next 90% is the 90% of the 90% that went on.
Okay.
Right. So it kind of resets back to because it's 90% of the total power, and so that 90% keeps going on, and you think to yourself, well, how do you get 90 out of 90? Well, 90% of the original power passes through, and then at the new tap, it's 90% of the new power that shows up, is what it is. And so you'll start. What's that?
Oh, so realistically, then you're saying that you start over at 0 after the split or the tap, and then it's 90%.
Well, you don't start at 0. So let's say that coming into the first 90 by 10, for easy math, let's say you lose 1 dB, right? So you go from 0 dBm to -1 dBm, right? And so when you arrive at the next tap, you arrive at -1 dBm. It's going to take 90% of that -1 dBm and pass it along. And so it's just taking a percentage of what arrives. And so the power keeps going down and down and down. And the goal is for us to have the power go down slowly. And so you might only rob 1% because you have 2 customers that are very close. So 99% of the power keeps going. And so you'll start with a low percentage split, and then it'll start to climb, right? Where it'll go from 99 to 1, 95 to 5, 90 to 10, and so they kind of start going down and down until the last one is 45 to whatever. So I hope that makes sense.
Yeah, it makes sense. I'm understanding now. So the one other question I had was, the benefit is to have smaller cables, but the initial cost of fiber is not really the cable. It's more of hanging it up or putting it in the ground. So there's no benefit to put a smaller cable necessarily because it's about the same price, whether, you know what I mean?
Yeah.
So I'm just trying to.
Yeah, ramping up, when you're first ramping up construction, you're absolutely right. Rolling out bucket trucks and real trucks and all that stuff, that's kind of a set fee, right? I think where the cost saving comes in, I'm not familiar with the cost of the cable, but I would imagine a 12 fiber would be cheaper than a large account fiber. But it's also lighter, right? And so you can get more cable onto a spool of fiber. Where the large account stuff, it's got a little bit slightly larger diameter, so you might have to splice them a little bit more often. And if you don't need that many fibers, right? I mean, it's nice. Don't be wrong. It's nice, to overbuild a little bit, right, and plan for the future. Somebody might throw a data center out there in the middle of Tonopah, which I think they're going to do. So you need, so having that infrastructure there is always a good idea. But for budgetary purposes, that might not be, something that's possible. There is a cost savings. I don't know exactly what it is. I know there's a market study. I'll look that up, and if I can find it, I'll attach it on there. But that was the understanding that I got. But you're absolutely right. The getting out there and putting up cable is a big bulk of the cost. But I think the idea of not having to upgrade the strand possibly, or not having to splice as often or as much, kind of adds to some of that value. So I'm not sure how much that trades off, but that's a good question.
Hey, Kevin. So you mentioned that on these unbalanced splitters, they can be 1x2, 1x4s, 1x8s, things like that.
Yep.
Say you have a 90-10 and it's a 1x4. Does the split ratio then say one fiber gets the 90 and then the other 3 fibers will share the other 10%? Or is it pushed specifically into certain strands?
It's shared to all 8, and so basically, so let's say it's an 8 drop. So in fact, let me go back a couple of slides here, and I can show that to you a little bit better. So because at that point it's actually a splitter, right? A true splitter, right? Like a passive splitter. So when we looked at this image earlier, right? So coming into this, again, so coming into this, let me get out my drawing pen here. We have that fiber coming in here, right? So it comes in. And of course, this is 100% of the power coming in, right? This is 100% of the power coming in. And as it comes through this terminal, there is a tap, actual tap here, right? And that tap will take the signal and then push the 90% over here. So 90% of the power is coming out. And then 10% of the power feeds all of these drops as equally as possible. We know how, sometimes it's not near as uniform as it should be. And so it's feeding all of these in here, right? And so, it doesn't feed one drop port with more power than another drop port. Not the, whoops, do that. I didn't mean to close my presentation there. It's feeding them as equal as that technology allows, I guess is the easiest way to say it. Hopefully that makes sense. Sorry, I accidentally closed my presentation here. Any other questions? Well, hopefully that was useful, well, valuable enough for your time at least. I know how valuable time is. So, but I'll hang tight here. If there's any additional questions, I'll ask them. If not, then from my perspective, I want to say thank you for joining us on this seminar.
Thank you, Kevin.
Thank you, everyone, for attending. Like Kevin says, and like I said before, we will be getting you some information, recordings of this presentation. Sounds like Kevin has some documents that he's going to feed over to me that we will get out to all of you, and if there's ever any questions that do come up, please don't hesitate in reaching out. Of course, the email will have contact information. And if you have an existing EXFO unit and want to look at if it can be upgraded, things like that, please don't hesitate in reaching out. Or if you're interested in this technology, let us know and we'll do what we can to assist you. If there's no other questions at this time, we'll go ahead and end. But we thank you and look forward to see you on the next one. And thank you, Kevin, for your expertise.
Absolutely. Anytime.
Thank you and goodbye to all.